Okay, now we'll see the AM versus FM comparison. So this is with respect to power, requires more power, and FM requires less power because only unmodulated carrier power. Envelope is not changed, it's constant. But here envelope is changing because this is amplitude modulation. Okay, so this is power efficiency, but here power efficiency is 100% only for those values of beta. Okay, in these case, here total power which is equal to sideband power and carrier is equal to 0. Power is independent of modulation index. Now here power depends upon modulation index. Now bandwidth is 2 FM, bandwidth is 2 into beta plus 1 into FM. So AM requires less bandwidth and FM requires more bandwidth. Now here bandwidth is independent of modulation index, but here bandwidth is depends upon modulation index. Okay. Now with respect to receivers. Now with respect to receivers. AM receivers are less complex. Complexity is very less in AM because envelope detector is used here. You know the envelope detector. Okay, very simple circuit. And here FM receivers, yes, FM receivers are more complex. FM receivers are more complex because here frequency discrimination method, phase discrimination method, phased lock loop, right? Balanced slope detector, ratio detector, complex circuits are used in FM. So demodulators are complex. Of course, receivers is demodulator is a part of the receiver. Therefore, receivers are more complex. Okay. Now this is with respect to power, with respect to bandwidth, with respect to receiver's point of view. Then we will see some other comparison with respect to some other parameters. Okay, no doubt. Now, fourth one, with respect to noise. You know that effect of noise is more in AM and signal to noise ratio is very less because here the information is itself in the form of amplitude, therefore effect of noise is more, but here effect of noise is less, is very less, not only less, is very less because here information is not in terms of amplitude, information in terms of frequency. Signal to noise ratio is very high, very high. Effect of noise is more because information itself in the form of amplitude, information itself in the form of amplitudes. Okay, so this is with respect to noise. Now with respect to broadcasting, what should be the specifications? Okay, and you already know that, but once again we'll see in the comparison. Okay, with respect to broadcasting, so the carrier frequency is 550 kilohertz to 1650 kilohertz. Intermediate frequency is 455 kilohertz. Bandwidth is 10 kilohertz because each audio signal is band limited to only 5 kilohertz. And number of AM tuned stations are, number of AM tuned stations are 1650 kilo minus 550 kilo by 10 kilohertz, which is equal to 110 stations. Now come to here, carrier frequency is 88 megahertz to 108 megahertz, and intermediate frequency is very high, such that image reaction ratio should be very high, and bandwidth, which is equal to 2 into beta plus 1 into FM, or 2 into delta F plus 2 FM plus God band, and a bandwidth which is equal to 200 kilohertz, and the highest audio frequency is band limited to 15 kilohertz. A number of FM tuned stations, number of FM stations are 108 mega minus 88 mega by 200 kilo, which is equal to 100 stations. And a practical frequency deviation maximum is 75 kilohertz. Okay. Now this is with respect to broadcasting point of view. And a best one, a modulation index is 100% is the best one. A modulation index beta, which is equal to 5, generally beta greater than 1, which is nothing but wideband FM. This is the suitable beta value, and this is the suitable modulation index. Now AM is here ionospheric propagation. Ionospheric propagation here. FM is a line of sight propagation. Right? This is a non line of sight propagation. This is the line of sight propagation. Now this is Earth. Now this is the ionosphere. Ions. Now this is transmitted, and here it is reflecting, again transmitting, again reflecting. Okay. Now but the problem in the ionospheric propagation, all frequencies are not reflected. All frequencies are not reflected. A line of sight propagation is now this is line of sight propagation. Now this is occurs at microwave frequencies or high frequencies, gigahertz or megahertz range. Okay. So the problem here is coverage area is more, but here this is line of sight propagation. Coverage area is limited, but the disadvantage here is frequency reuse concept is not possible here, not used, not possible. Frequency reuse technique is possible. Frequency reuse concept is not possible. Effectively, we can utilize the frequency. Effectively, we can utilize the spectrum if the frequency reuse concept is possible. But here, frequency reuse concept is not possible. But here, frequency reuse concept is possible, because this frequency reuse concept, which is nothing but used in mobile communication. Now, the total area is divided into some subcells, cell site. Okay. Then the same cell site frequency at first cell site and fifth cell site. Adjacent cell sites are not same frequency. The same frequency we can reuse after some cell sites. Okay. So that concept is nothing but frequency reuse concept. Generally, it is used in mobile communication. Okay. So this is advantages of high frequencies. Frequency reuse is possible, but coverage area is limited. Advantage of low frequencies, coverage area is more, but frequency reuse concept is not possible. Okay. Right. This is actually AM versus FM. Now that super heterodyne receiver is used in the satellite communication, TV applications or radio applications. Okay. Now that is where super heterodyne receiver is used, and almost all the communication applications are used super heterodyne receiver, radio or FM radio or TV communications, satellite communications. The super heterodyne receiver is used. Okay. Hold on.